Salutations class. In this video, we will be reviewing factoring. For our first example, we want to factor the expression x squared minus 14x plus 24. Remember that when we factor, it's basically undoing FOIL, so the opposite of FOIL. Remember, FOIL is for multiplying two binomials, so two sets of parentheses that have two terms inside each. In order to figure out what to put in these binomials, we need to look at three things. First, we need to look at the coefficient, or the number, next to the x squared term. Notice here we don't have a number, which means there's an invisible 1. If you don't have a number out front of the x squared term, we can just put x for our first term in each of the binomials. Next, we want to look at the signs in front of our x term and our constant. Notice here we have negative and positive. When we have negative in front of the x and positive in front of the constant, that means both of our terms, both of our binomials, need to be subtraction. So now I can set up my signs for the binomials. Lastly, we need to look at the constant and the number in front of the x term. And remember, we always want to look at the entire sign. So our goal in order to find what goes in these two missing spots are two numbers that when multiplied give us 24, but when added give us negative 14. I just happen to know that if I take the number 2 and the number 12, negative 2 times negative 12 is going to give positive 24, but negative 2 plus negative 12, remember when we add a negative, we get a negative answer. So that's going to give us negative 14. So here's our solution for factoring this first expression. Our next example. Again, in order to solve these, we want to set up our two sets of parentheses. We look at the coefficient in front of the x term. Since there's no coefficient there, we can fill in the first parts with just x's. And now we look at the signs. Here we have a plus sign, here we also have a plus sign. When both of them are plus signs, we can put plus signs in both our spots in order to fill in our signs. Now, to fill in the last sets, remember, we need two numbers that when multiplied give us 18, and when added give us 9. In order to find this, another helpful trick is if we do a factor tree. Notice that the factors of 18 are 2 and 9, or you can multiply 1 and 18, or you could also multiply 3 and 6. Well, if I multiply 3 and 6, it gets me 18, but notice that 3 plus 6 gives me 9, whereas 2 plus 9 gives me 11. I don't want to use 2 and 9 because that adds up to 11 and not 9. So here, I know I want to use 3 and 6. Now on to our next example. Again, make sure you have your two sets of parentheses. Again, we don't have a coefficient out front of the x squared, so we can fill in our x's. And now we have a plus and then a minus. Here, that means we need one plus sign and one minus sign. This one's a little bit trickier, as we now need to find two numbers, again, that when multiplied give us negative 12, but when added give us positive 4. So I can do my factor tree for 12 again, and I can say, hey, this has 1 and 12, which if we multiply gets us 12, but if we add them, that's going to get us either negative 12 plus 1, which is only negative 11, or if we have negative 1 plus 12, that's going to get us positive 11. So what about 12 is 2 times 6? Well, if we add 2 to negative 6, that's going to get us negative 4. But what if we add negative 2 to positive 6? Then we'll actually have our 4. So here we want positive 6 and negative 2 are our answers. Now let's try some slightly different examples. Notice here the difference between our last slide's examples and this one is that we have a number out front of our x squared term. So here we want to make sure to find the factors of that, which are only 2 and 1, and we need to take those into account when doing our x terms. So here 2x and 1x, because those are our factors of 2. Again, we check our signs. Here we have negative and negative, which means we need one negative and one positive. I'm not going to put those signs in just yet, because notice here, it's a little different with the 2 here and the 1 here. It's going to take a little more care to figure out. So while we still want to find two numbers that when multiplied give us negative 6, now we have to consider that we multiply one of the numbers by 2 when we add up in order to try and find negative 11. So here I'm going to try the factors 1 and 6. If I make the 6 negative, 1 times negative 6 is going to give us our negative 6 that we want. But notice now, if I put the negative 6 here and the positive 1 here, I need to multiply 2 times negative 6, which will get me negative 12, and then 1 times x gets me 1x, so that's going to give us negative 12x plus 1x, which will give us our negative 11x. So these ones take a little more thought. Remember, if you're ever worried about what your answer is, FOIL it out and double check. These ones can take a lot of guess and check work in order to solve. Our next example, 6x squared plus 13x plus 2. Again, I want to make my two binomial terms. But here, notice in this one, we've got more than two factors. So we could do 1 and 6, or we could also do 2 and 3. So now we have lots of guessing and checking to do in order to plug in, say we put 2 here and 3 here, or maybe 6 here and 1 here. I'll put the 1 just to remind us that we used the 1. And then for 2, fortunately, we've got an easy of our only factors are 1 and 2. So we just need to figure out where the 1 goes, where the 2 goes. If we check our signs, they're both positive, so that means we can use positives here and here, as it doesn't matter. And now we can check where we want to put our 1 and our 2. If we put our 2 here and our 1 here, 6 times 2 is 12, and then 1 times 1 is 1, so 12 plus 1 is going to give us the 13 that we want. Again, I'm making these look a lot easier than they are because I've already worked out the problems, but it really comes down to a lot of guess and check and using those factor trees over here. Now on to our next problem. I'm going to move along to a different type of example entirely. So here we have solve the following equation. Notice here we've got an equal sign to deal with. So this is a slightly different problem. In order to solve these types of problems, we still want to do our factoring, but now we have to solve the factors in a second step once we're done. So what I'll do is I'll bring down my binomials, because I still want to factor, and then bring down the equal to 0. A huge thing to look for in all these types of problems is we always want it to be equal to 0 on one side and have everything else on the other. Here we've got a number out in front, so we're going to need a 2 and we're going to need an x, because those are the only two factors at 2. We've got a negative sign and a negative sign. So since we have a negative sign for our second sign, that means we're going to have one positive and one negative. We don't quite know yet where each is going to go. We need to find two numbers that when multiplied get us negative 10. Factors of 10 I'll do over here. We've got, in fact, we want negative 10, so we could do negative 2 and positive 5. We could do -5 and +2. Remember, keep doing all these factor trees in order to find the ways that you're going to guess and check. For this particular problem, I'm going to try out -5 and +2. So I'm going to put +2 here, and -5 there, and I'm going to real quick FOIL to double check and make sure I'm correct. 2x times x is going to give us the 2x squared, and then 2x times -5 is going to be -10x. 2 times x gives us a +2x, and then 2 times -5 gives us our -10. If we simplify that down, -10x plus 2x, that gives us our -8x that we wanted. So that means our equations are correct. But now that we factored, we're still not done. We now need to solve 2x plus 2 is equal to 0, and we also need to solve x minus 5 is equal to 0. For this one, we can subtract 2 from both sides, get 2x is equal to -2, and then if we divide both sides by 2, we'll get x is equal to -1. To solve this one, it's a lot easier. All we need to do is add 5 to both sides, and that gets us x is equal to 5. So for our answer for this problem, we actually want x is equal to -1, also, comma, 5. So here's what a solution should look like for this type of problem. We can have multiple answers for our x. Moving on to the next one, again, we want to factor it. But before we factor, we want to make sure that there's 0 on one side of the equation and our polynomial on the other side. I happen to know that in order to factor this one, it's just 4x minus 1 and then x plus 3. Again, if you want to solve that, use your factor trees and a lot of guess and check, trial and error. I'll save foiling it out to verify for you to do on your own if you're interested. But the next step, the important step for these equation ones, is we need to set each of the factors. So 4x minus 1 needs to set equal to 0, and we also need to set x plus 3 equal to 0. So here we add 1 to both sides, and we get 4x is equal to 1. Then we can divide by 4 on both sides, and that's going to give us x is equal to 1/4. Then for this one, again, it's a lot easier. Subtract 3 from both sides, and we'll have x is equal to -3. So our answer for this is going to be x is equal to 1/4, comma, -3. We have multiple answers for this again. And for our last example, notice here it's slightly different. We don't have just 0 on this side of the equation. So what we need to do is make sure that we do have 0 on one side of the equation. And in order to do that, we can subtract. So that's going to get us x squared plus 3x minus 10 is equal to 0. Now that we have it set equal to 0, we need to do our factoring. This one I also know factors to x minus 2 and x plus 5. Again, if you'd like to verify that, you can check it at home. Now we need to do x minus 2 is equal to 0, which brings us to x is equal to 2, and then x plus 5 is equal to 0, which by adding 5 to both, or subtracting 5 from both sides, is going to give us x is equal to -5. So our answers for this problem are x is equal to 2 and -5. That's been our review on factoring. See you in class.